Hello and welcome to this video on regression. How do we find regression? Here we will learn how to find out regression equations for y on x. That is, y is a dependent variable and x is an independent variable. So y is dependent on x. So what am I saying? Y on x. So this is the regression equation that we'll learn to form today. Now, as y is dependent on x, so y should be a function of x. So y should be equal to some function of x. And maybe if at all there is an offset or mathematically an intercept. So y is a function of x. Y is equal to a plus bx. This will be my final solution. This is my regression equation. So when you get a question where you need to find out regression equation, this is the equation that you need to find out. Alright. Now, what do I mean when I say you need to find out this equation? When I say that you need to find out this equation, you actually need to find out value of a and b, because these are the variables that are defining relationship between y and x. Fine. Now, in order to find out this relationship between y and x, we need to find out values of a and b. And in order to find out values of a and b, we'll be needing certain other equations that could help us. We need to frame certain equations which we will solve simultaneously to get values of a and b. And those equations would be sigma y is equal to na plus b sigma x. So technically, if you see, what I have done is y is equal to a plus bx, y is equal to a plus bx. I have taken summations of these variables. And now, here we have our second equation. I'll multiply this, literally I'll multiply this complete equation by x. So what happens is, this y becomes xy. We get a sigma x over here because we were not having a x over here, and then we have b sigma of x square. So because we were already having an x, so it becomes an x square. We were not having an x, so we get xy. No x or variable was available here, so we get an x. So these will be my two equations which I will solve them simultaneously. Okay, and I'll get variables values of these a and b coefficients that are defining the relationship between x and y. Okay, now let us take a small example, a very simple one. Let's say we have x and y. Okay, so let us put some simple values: 10, 20, 30, 40, 50. And here maybe let us put 7, 8, 14, 25, 46. Okay. Now, if you look at these equations that we need to solve simultaneously, what do we have? We have a summation of y, we have a summation of xy, summation of x, again being used here, summation of x square. So in all, we need three different summations. One is sigma y, sigma x, sigma x square. Okay, then this one also, sigma xy. So 4 different summations I need. Okay, let me go ahead. Sigma x, sigma y, sigma x, sigma y, then xy and x square. So let me make 2 more columns over here of xy and x square. Okay, now what will be xy? It will be 10 into 7, giving me 70. 20 into 8 giving me 160. Then you have a 420, 1000, and 46 into 50 would give me a 2300. Then there is this x square, nothing but square of these x values. 10 square of 10 would be 100, 20 square of 20 would be 400, 900, 1600, and 2500. Fine. So I have all these values done: x, y, xy, and x square. X, y, xy, and x square. Now let us also find out sigmas of all these values, summations of all these values. Their summations would be 150. If we add these, we'll get 100. Here we'll get a 3950. X square would give me a 5500. So these are the values. Now let us go ahead and put these sigma values 150, 100, 3950 and 5500 in their respective places in these equations. Okay, so what do we have in equations? We have first equation as sigma y. What is sigma y? It is 100. Sigma y is equal to 100. So instead of sigma y, I'll write 100 is equal to NA. N is number of pairs that we compared. 1, 2, 3, 4, 5. These were the 5 pairs that I used for all the comparisons and all the calculations. So N would be 5. A, we do not know its value because we actually wish to find its value. Then instead of X, I will put 150. So it becomes 150. B I am leaving as it is. Now it doesn't really matter if you make it 5A or A5. 5A is good. B150 or 150B is good. But mathematically it makes more sense if we write the constant value before the variable. So instead of writing it as B150, it looks better when you write 150B. Next is sigma xy. Sigma xy, we have 3950. It will be 3950 is equal to A sigma x. Sigma x was 150, so I get 150A. Sigma x is 150A. Then what do we have? Plus x square b. X square is 5500, so we will get 5500 b. Now when I substitute values of these summations in these two equations 1 and 2, I get this pair. Now all you need to do is solve these equations simultaneously. Probably we all have solved these equations at some point of time in our lives, but if we do not remember, no issues, we'll solve them once again. Now, as these video tutorials are targeted for the scholars, students from non-mathematics background, so I will generally keep an approach which is more suitable for non-mathematics students. So under that approach, I'll give you a thumb rule that you should always follow. And the thumb rule is you multiply this first equation, complete first equation, by coefficient of A in the other equation, which is 150. Okay, so I'll multiply first equation with coefficient of A in second equation, which is 150. Fine. And then what I'll do is I'll multiply the second equation by coefficient of A in first equation, that is 5. So I'll multiply the second equation by 5. Now what this does is it will change the shape of these equations. This equation, for example, will change somewhat. 150 multiplied by 100 would give me 15,000. 150 multiplied by 5 would give me 750, and 150 into 150 would give me 225,000 p. So first equation has changed into something else. Okay, now let me multiply this second equation also. Now I'll take this second equation and multiply it to 5. What do we get? 3950 multiplied by 5. It will give me a 19750. 150 into 5 would give me 750A. 5500 multiplied by 5 would give me 275,000 p. This. Alright. So this was simple. We can multiply these equations. Now that we have multiplied these equations, let us go ahead and subtract the second equation from first equation. Okay, this becomes my first equation. After I have substituted, this is second. Let me subtract second from first. So in order to do that, I will have to change the signs of second equation. So this 19750 becomes a minus 19750. This 750 becomes a minus 750. This 27500 is minus 27500 now. And when we try to add these two equations, 750 minus 750, they are cancelled. 15,000 minus 19750, giving me 4750. And here we get minus 4750. Here we get 5000 p, rather minus 5000 p. So what will be the value of b in such case? It will be minus 4750 upon minus 5000, which in turn, if you try to solve, we have minus on both ends, numerator and denominator, so they'll cancel each other out, and 4750 divided by 5000 will give you 0.95. So I get value of b is equal to 0.95. This is value of b. Now let me substitute this value of b into any equation. Let's say this one. Let me substitute value of b in this equation. I'll put 0.95 in place of this b. This 0.95 over here. And let us see how it shapes up and how we get value of a. We get 100 is equal to 5a plus 150. Instead of b, I will write 0.95, exactly 0.95. Okay, so if you solve it, you will get 100 is equal to 5a plus 142.5. Now I can take this plus 142 on other side, and what happens when I do so? the sign will change. So let us go ahead and send it over there. We'll get 100. This 142 goes to other side of equal, becoming minus 142.5. Remember, it is plus, so on that side it will become a minus. Is equal to 5a. When you subtract this, you will get minus 42.5 is equal to 5a, giving me a is equal to minus 42.5 upon 5, and when you solve it, you will get minus 8.5. So this gives me value of a is equal to minus 8.5, right? So we have b as 0.95 and we have value of a as minus 0.85. Let us go ahead and put these values in our important equation, the regression equation of y on x. What is the equation? Do we remember it? It is y is equal to a plus bx. This is the regression equation. So now that I have values of a and b, let me put them. Y is equal to a, that is minus 8.5, plus bx. b is 0.95. Here it is 0.95. Okay. So it will be 0.95 x. This is my final regression equation that we were trying to find out. And just a tip, this 0.95 is called regression coefficient. Regression coefficient of y on x. This b value is known as regression coefficient of y on x. So next time when we meet, we'll take some other example of regression and we'll see if we can find out equation of x on y. Right now we were doing y on x. We'll try to find out x on y. Until then, thanks for watching. Bye bye.